Hello, welcome to Bonding Theories. Today we're going to be talking about covalent bonds, the molecules they make, and more than that, the shape of the molecules that are made by covalent bonding. And so to do that, we're going to talk about VSEPR, VSEPR, is the acronym here, and that's valence shell electron pair repulsion theory, which sounds like a lot of big words, but really we know a lot of them. Valence just being the outside shell or level. Electrons, valence electrons, tend to make pairs, whether that's an orbital that can hold two electrons and it's not shared at all, or if it's a covalent bond is a shared pair of electrons. And so electron pairs repel each other because they're negative, and negative repels negative. And so these pairs of electrons are going to repel other pairs as much as they can, or they're going to be as far apart around the central atom as possible. And so that's what we're thinking about. And these pairs, again, could be bonded pairs, like covalent bonds, or they could be unbonded pairs, like these unshared pairs. And so we can think about if you were to hold a group of balloons, like here we've got 4 balloons. If you were to hold them all in the center, how would they spread out? Well, as much as they possibly can. They're going to push each other away from each other. If you had one that was slightly bigger, that's on the bottom here, one balloon that's a little bit bigger, one big balloon and 3 smaller ones, if you held them all in the center, again, that big balloon is going to push the others down just a little bit more. So some shapes that we see a linear shape if your central atom's in the middle and you got 2 things on the outside. As far apart as possible, 180 degrees would be the bond angle. That's as far apart as it goes. Some other ones, we got trigonal planar. They use fancy words here, just kind of adding the alls on there and ers and whatnot. It's a triangle. And it's in one plane, so that means it's flat. We're thinking about these, most of them are 3-dimensional. This one would be flat or planar in one plane. There's a bent or angular kind of thing, bent. And then tetrahedral. That one looks a little bit weird. It looks like this. So the way that we put 4 balloons together is not flat like a piece of paper, but it takes up all 3 dimensions. And so the farthest we can get is actually 109 degrees here versus 90 degrees. If you made it flat like a piece of paper, they'd be 90 degrees apart. 109 is bigger. Trigonal planar, or a triangle in one plane, that would be if we were to look at like this, if we had an unshared pair on the top. So then we look at this, it's triangular, or pyramidal, sorry. So it's a pyramid. So it's not quite in a plane. We can see that the yellow ones are, but the black one is up above. So it's a pyramid. And then bent or angular, again, would look kind of like that. So those are some shapes. Here's some examples. Linear would be like this carbon dioxide molecule. And the reason is that there's no unshared pairs on top. We just have the 2 spaces where there's electrons. There's shared pairs in here and shared pairs in here, and so it's really just holding those like 2 balloons together. They're going to be as far apart as possible, 180 degrees. Trigonal planar looks like this one. Again, there's no unshared pairs here, so there's just 1, 2, 3 things as far apart as we can get them. It's 120 degrees, and in a triangle in one plane. The bent ones, it starts to look like this. It's bent because you have unshared pairs. There's actually 2 unshared pairs here on oxygen. And so the reason for that is that, think about, you're holding 4 balloons around the oxygen here. You've got 2 bonds and then 2 unshared pairs. Likewise with the trigonal pyramidal, trigonal pyramidal, you're actually holding 4 balloons here. You've got the unshared pair on top and then the 3 covalent bonds. And so that's why you can see the kind of the pyramid shape of that one. Tetrahedral, again, looks like this, where you have 4 things, and so there's no space where there's no unshared pairs on that one. And so we can kind of think about how many atoms are bonded to the center. If you just have one, it's just two atoms. It's going to be a straight line. Doesn't matter what else is there. If you have two atoms and no lone pairs, then that's going to be straight also. You can imagine that's like that CO2 where you have the central one and then the two on the outside. Trigonal planar would be you have the three things and no lone pairs, where trigonal pyramidal, that was this one, had three atoms and a lone pair. So you had four things. That's why the unshared pair pushes those three down. Bent could be if you have two things, if you have some lone pairs. Two things together would be straight or linear if there's no lone pairs. But as soon as you have these unshared pairs, they start to push those down towards each other. This one would be more bent because you have more lone pairs. And then you have the tetrahedral, again, which is four things spread out as much as they can. So those are some shapes to look at. I hope that makes sense. Have a great day.